This is the third section of the Unit 4 revision podcast on energy. This section focuses specifically on heat energy. The learning intentions then for this section of the podcast or videocast are to explain the three forms of heat transfer. You should already know these. Be able to describe each form of heat transfer in terms of particles or waves. You need to be able to explain the difference between conductors and insulators and explain absorption and emission of radiation. By the end, you will be able to describe mechanisms of heat loss and how we can reduce them. Describe how particles are affected by heat in terms of solids, liquids and gases. Describe how different materials expand and explain then how allowances are made for forces created by expansion in different structures. So these are the learning intentions that this videocast will address. Let's start firstly with a definition. Often people get confused between the two terms temperature and heat. They're very different. Temperature is measured in degrees C or degrees Fahrenheit if you use the older measurement, or the SI unit is Kelvin. And it is a measure of how hot an object is. Heat, on the other hand, is measured in joules. And it is a measure of how much energy is needed to change the temperature of an object. So the temperature measured the hotness, and the heat is a measure of how much energy will change the temperature of an object. Heat is transferred from hot to cold areas of an object by one of three methods. So there are three methods of heat transfer: conduction, convection and radiation. And we will be describing each of these forms and looking at applications that use each of the three forms. If something is at a lower temperature than its surroundings, it absorbs energy or takes in energy. If it is at a higher temperature, it releases energy or gives it out. Just to clarify temperature and heat then. We're looking at a cup of water at 40 degrees C and a bath of water at 40 degrees C. Which is at a higher temperature? Well, the answer to that, they're both at the same temperature. But when we look at it, which one contains the most energy then? Will the cup of water at 40 degrees have the most energy, or will the bath of water at 40 degrees C have the most energy? Well, the bath is going to have the most energy as it has a greater volume of water and will be giving out more heat from its surface than simply from the cup. Heat transfer then. During heat transfer, thermal energy always moves from hot to cold. If something is at a lower temperature than its surroundings, it absorbs energy, and if it is at a higher temperature than its surroundings, it releases energy. To remind ourselves the three mechanisms of heat transfer: conduction, convection and radiation. And in most cases, or in several cases, you will find that all three could be happening at once. In this example, we have a fire that is radiating heat, and radiation is by heat waves, and the heat is being conducted through the metal surface of the saucepan into the water, and it's also being conducted via the metal surface of the handle to the person's hand. And then within the water, the heat is transferring by convection from the warmer part of the water at the bottom of the saucepan up to the colder part initially at the top. So the conduction, convection and radiation are occurring at the same time in that example. So to define conduction then, well, firstly it happens in solids. Heated atoms vibrate more, and as they get warmer, the atoms then collide due to those vibrations with neighbouring atoms and pass the heat or energy along. So heated atoms vibrate more, and as they get warmer, those greater vibrations cause collisions with neighbouring atoms. They pass on the heat or energy along through the chains of atoms. This is a slow process, It's less important in metals, a reason we will discuss in a second, but this is the only way that non-metals can pass heat along. So examples of non-metals are your polymers, wood, plastic and so on. This is the only way they can transfer is by this vibration of atoms, and colliding with neighbouring atoms transfers that heat energy. Metals are slightly different. They conduct heat well because they also contain free electrons. And when those free electrons pick up energy from the heating, they can actually move through the structure of the atomic structure of the metal, and they carry heat from the hot to the cold areas. So within metals, conduction is by movement of free electrons, and within non-metals, it's by vibration of atoms. And it's a lot slower within non-metals, as you would expect. So examples of conductors and insulators. A conductor is a material which will conduct heat well. An insulator is a material which does not conduct heat well. So examples of good thermal conductors are metals and also graphite. Examples of thermal insulators, those who are good at preventing conduction, are wood, plastic, paper and glass. And many of the insulators that we use to prevent heat loss from our houses and so on contain pockets of air. And that's a very important point with regard to insulation and preventing heat transfer by conduction. Insulators contain pockets of air. If you trap air and you prevent its movement, it's a very good insulator. It does not conduct heat. So if you can find a way of trapping air, for example, within expanded foam or so on, once you trap that air, it's a very good insulator and prevents heat loss by conduction. Moving on then to convection. Convection is the transfer of heat through fluids. In other words, liquids and gases. As particles are heated,